Hey, Professor.
Yes.
No, my bad to interrupt you. This is
Mhm.
it's Peter. So I'm on my phone right now, but I have a power outage over here.
Oh man,
So
okay.
yeah, so I'll just give you a heads up. I guess just checking in with you to let you know I'm here, but I'm not gonna stay in the meeting because I don't want to kill my phone battery because I don't know how long the power's gonna be out.
Okay, cool. I appreciate you letting me know. Hope things get back on for you soon.
All right, appreciate it. And then you
Yeah.
say can I get an email of today's lesson?
Yeah, most definitely. Most definitely.
Okay, appreciate it.
Yep, no problem. All right, have a good one. All right, so 4.1 exponential functions. So let's call this the exponential. All right, so here we have the exponential function f with base b is going to be represented by one of these right here. Don't forget f of x and y are interchangeable. F of x is in function notation. Using y means that you aren't. And also recognize that x is your exponent. It's not just a regular x. That's not b times x. That's b to the x power. All right. And you have b is a positive constant other than 1, and x is any real number. So, all right. So this is an example of an exponential function. F of x is equal to 2 to the x. So if we want to graph it, we can look and see how that would be different as far as graphing is concerned versus x being just a regular term or regular variable. And if I scroll up too fast, always feel free to let me know. We do this more. All right, so whenever we're graphing, one of the ways you can do so is by creating an XY chart, choosing your X values, and then plugging them in to find the corresponding Y value. So plugging in 3, 2 to the third power is 8. So when X is 3, Y is 8. Plugging in 2, that'll be 4. Plugging in 1, 2 to the first power would be 2. Plugging in 0, anything to the 0 power is 1, so don't forget that. Any questions on those before we do the last 3? All right, so plugging in -1, that's 2 to the negative first power. And so to get rid of that negative exponent, you drop it down to your denominator. So that's 1/2. Plugging in -2, 2 to the negative second power, 1/2 squared, and that's 1/4. And then the same thing with the negative third power. And that's 1/8. All right, before we graph it, questions? Any questions? All right, so we know it's going to be 3, 8. So we go to the right, 3 up 8. And that was 2, 4. And 1, 2. Go up 1. Then 0. And we're going off of these order pairs, 0, 1. Then -1.5. So that'll be right here. Then -2, that'll be 0.25. Then -3, I believe that's 1.125. And you can see the shape, the general shape of your exponential function. So that's what that term comes from when it says something grows exponentially. It means it's growing real fast. Notice how it goes up. If you keep going to the right, it goes up quickly. 2 to the 4th power would be 16. And then 2 to the 5th power, 32. 2 to the 6th power, 64, and so on. It'll keep going up, going up, going up very quickly. So that's what we mean by something growing exponentially. It grows quickly. Questions on that? All right. So next thing you talk about are your transformations of your graphs. You can spend time on that. We've done that before when if you were to do 2 to the x plus 1 versus 2 to the x and then have plus 1 down here, how does that change it? So if you play with graphing tool, you'll see that. My math lab will probably give you some graphs, say which one is which. So, take a look at that. I won't spend too much time on graphing. You guys are graphing pros at this point. So, same concept. Let's see, are they giving us anything on that? All right, I'll just do this. E to the first power. So here we have our natural base E. It's a function. So you see E in your calculator. If you have a scientific calculator, you should see E somewhere. Sometimes it's connected to this button, natural log, and we'll talk about that in a section or two. Your natural base is used oftentimes when you're talking about something growing exponentially or something growing or increasing in value quickly. You see, they didn't do anything with that really. Okay, just introduced it. Okay. So make sure you can use that and find that in your calculator. If not, always feel free to get with me so we can talk about the option of your calculator, see if I can help you out. So we're going to come back to this when we get into our natural laws. They just introduced it and emphasize how, make sure you have the capability of using it. Now, we are going to use it in this next application, talking about compound interest. How do I want to start this off? All right, so compound interest for n compounding periods per year. A is equal to P times 1 plus R over N raised to the N times T power. And then for continuous compounding, A is equal to P times E to the R times T power. So E is your natural base, what we just finished mentioning. So I'm going to write down what AP, RN, and T all represent in a second. But also first establishing what does it mean to be a compounding. That's when you put some money in your account, how many times is the interest going to be applied per year? So that's what you're talking about. How many times will it be compounded per year? So P is the principal. And that's going to be your deposit or loan. R is your rate. Don't forget to convert that to a decimal. T is your time. That should be in years. And is the number of compounding periods. Per year. Oh yeah. And A is the future value. So how much money you expect to be in the account after so many years. All right. All right. Also, let's go here. Number. All right. So, if you haven't dealt with these formulas before and the wording that they use, when you talk about the number of compounding periods, normally they don't give you the number. They give you a key word that lets you know what that number is or what that number will be for n. So, in other words, if you have annually, that means n is equal to 1. That means it's compounded once a year. Semi-annually, n is equal to 2. Monthly, n is equal to 12. Probably should have went quarterly. N is equal to 4. Weekly, n is equal to 52. And then last one, daily, n is equal to 360. And so it's going to be 360 instead of 365 because of what they call Banker's rule. And being compounded daily is different than being compounded continuously. So notice for continuous compounding, you use a whole different formula than you do for actually having compounding periods. So it's two different formulas. All right. Percent per year compounded monthly pays. All right, so you decide to invest $8,000 for 6 years and have a choice between two accounts. First pays 7% per year, compounded monthly. The second pays 6.85% per year, compounded continuously. Which is the better investment? So I'll give you a chance to write that, and then we'll do the problem. All right, so let's look at each account individually, so what information we have for them, and then go to calculate. So the first account, P, the amount we're depositing is 8,000. The rate is 7%. Time is 6 years. And N is, we are compounding monthly. Oh, I didn't even do that. So that means N is 12. All right, so that 7% goes to 0.07. And we should be able to plug it into the calculator now, or to the formula, I should say. So it's going to be 8,000. And then 1 plus 0.07. I'm going to bring it down so I can have more room. 0.07 divided by 12 raised to the n, which is 12 times 6. So depending on your calculator, the type of calculator that you have, you could actually put it in just like that. If not, then you have to follow order of operations, do the inside of the parentheses first, and then raise it to the power, then multiply it. So, but if you have a calculator that allows you to put parentheses up, you can put it in just like this. And that will be 12,160 and 84 cents. All right, so that's coming out of the first account after 6 years. All right. Second account, the amount we're depositing is still 8,000. The rate this time though is 6.85, 0.0685. Time is still 6 years. But this time, we compounding continuously. How do I write it? So we use a different formula as we talk compounding continuously. So it's 8,000 e to the r, which is 0.0685 times t, which is 6. I'll use a decimal, not decimal, but multiplication point. All right, so you should be able to put that in the calculator as well, just like that. And that will be $12,066.60. All right. So if we were to compare our money and what would be in the account after 6 years, see our first account gives us $12,160.84, and the second account will give us $12,066.60. So this first one would be the better investment. All right, questions. See, how many days do we have left? Yeah. All right, so looking at what we have left, today is the 11th. So we're looking at 11, 18, 11, 16 the next week. Yep. I know it's 11:30. That'll be 12. 2. Yep. Times 9, so this should be 6. 12, 2, 12, 9. Oh, 7. I did 6. All right. Yeah. 14, 16, 12, 12, 18. Okay. So next week we'll cover more chapter 4. I don't know if we get done or not. But chapter 4 is next week. No class this week. That's Thanksgiving week. So give you guys a chance to get caught up on work and get caught up with the family. Then here we'll look to finish chapter 4. And because we may be finished chapter 4 here. But I say at the most, we will be need 11:30 to finish chapter 4. So that means our final test. Remember, we have to do at least one final. Proctored. Remember, all of the other tests have not been proctored. So what I am thinking is that finish what we've done here. Probably, I'm not going to try to make it too long. So let me see how long it will be, because what I want to do is either do it on one of these 2 days or do part 1 here, part 2 there. Depends on, because we're not going to be able to set aside a 2-hour block. So we're not going to be able to set aside a 2-hour block. So we just have regular class time. So I'm trying to make sure that whatever we do is we'll fit within that class time. So between these 2 days, and then the rest of the time will be for you to get caught up on your My Math Lab work. And we have until the 18th, as far as SIS is concerned, to get your work completed. All right. And let me see. Yes, I will be proctoring the test. And so what will happen is I will take the Zoom session. I will take the Zoom I'll give you another Zoom link, and what will happen is you will make sure that your cameras are enabled, and make sure you bring an ID with you, and to confirm, you are who you say you are, and yeah, we'll go from there. So yep, I will not send you off or send you away. Now, if you need, now I don't know if it's this class or not, but some people have, accommodation sheets. They need double time and stuff like that. So now, if you need double time, then you will have to go to the testing center. And so, for those individuals, you will set it up, with the testing center, and they will email me individually, and we will make sure that you are straight. Um, any other questions on that? What I've written? Everybody good? Everybody straight? So, yep. There's no rush to jump into more of chapter 4 today. I was looking at my math lab, and some people need the time to get caught up. Some people are still in the early stages of chapter 3. But of course, we can't just keep doing nothing. So that's why we did 4, 1. Let's see, somebody in the chat. Just another question. Has everyone finished chapter 3 test? Oh, no. Everyone hasn't finished chapter 3 test. So if you haven't finished it, you most definitely are in, you have company. So it's no big deal. So that's why I only did, not a problem. So that's why I only did 4-1 today. It's just that we don't have the luxury of not doing anything to make sure that everybody, has a chance to be on task, because I don't want to do nothing when there are other people who are ready, to move on. So we do at least one chapter, one section, and give others to opportunity to get caught up. And so next class, we'll look at 4-2, and then go from there. And of course, if you have questions, some questions are generated over the weekend. We'll most definitely answer those questions on next class as well, because I don't believe 4-2 would take up the whole class period. So, yep. So, questions? Any other questions, concerns, or comments? And I'll create a review for that final test as well, so you'll know what it will be on it. All right. Also, don't forget, any test that you submit through my math lab, your take-home test. Make sure you send me copies of those of your scratch sheet, your scratch work. If we have an A in the class, do you have to take the final? Actually, TCC stopped allowing us to do that, unfortunately. So yeah, you kind of got to take it. Now, what I will say is, I may create a little caveat in there wherein I won't allow it to hurt your A, but I still have to have evidence that you took the exam. So, yep. So let's say if you don't do as well as you like, I can find a way to not let it hurt your A, but we still got to take it though. All right, cool. Try to meet y'all halfway. All right, so any other questions before we close? Everybody good? Straight? All right, you guys have a great one, and I will see you on next class.